Welcome back to our MOOC, Teaching Science in Universities. In this next part of the MOOC, we want to tell you how you can use analogies to help your students to understand abstract topics. And we want to tell you how you can make invisible science concepts visible to your students. Looking back to your own learning in science, you might have experienced that those lecturers who were using narratives, who were using analogies, who were using metaphors, were the ones that brought the most fun to you and brought the most understanding to you. We want to start the first lesson with to explain you why this was so helpful in understanding abstract topics. And I'd like to start to show you some research from school science education. We have made a study in a 7th classroom, in the 7th biology classroom, where students were taught about immune biology. And we asked the students about their understanding of these topics, and we asked them to draw pictures about their understanding. And here we have Christina, a 7th grade student who was typical for the statements we got. She said something like, "Then there are coming the antibodies so that you do not fall ill. They are attacking the virus, and when you have a strong immune system, then the antibodies will win. And when you have a weak immune system, then they will lose and you become ill." And she has drawn a picture with a tank and some small people or spots with weapons in the hand. We first thought that, this is school science. Students in school often use metaphors, often use analogies to understand something, but when they grow bigger, then they take away these analogies and they develop a real scientific understanding. We had a closer look at the things they have written to us and at the pictures they have drawn to us, and what we have found is they used analogies like attacking, strong, win, weak, or will lose. So obviously they refer to the idea of fighting or of war to understand the idea of the immune system. After that, we had a look into university textbooks, because we thought, hey, perhaps for students in school it's okay to use analogies, it's okay to use metaphors. When it comes to communicating real science content, we have to take away the analogies. And here's a small excerpt from undergraduate textbook, and this is saying, "T killer cells have the ability to identify and to kill virus-infected cells. Activated T helper cells cooperate with B lymphocytes and are important to fight against intracellular infections by bacteria." When we have a closer look at these texts, we see that they are using the same analogies. They are talking about identifying, killing, cooperating, or fighting against. So obviously these guys are taking the same analogies to communicate a science topic. We thought, okay, perhaps in other graduate studies they are using analogies because to help these poor students to develop a scientific understanding. And to be sure about how analogies and why they are used, we used the papers of Nobel Prize laureates. In 2011, the Nobel Prize in Physiology or Medicine was given for some research that has been done in about the immune biology. And we have analyzed a paper on this too. And what we have found is that even these experts, even these guys who got a Nobel Prize, they were using analogies. They used terms like protect, target, deficiency, faulty, delete, neutralize, resistance. So they were using analogies from the same field. They were using analogies from the field of war, from the field of fighting, to understand and communicate their topics. And we have taken a paper in a peer-reviewed journal. So this was not a paper for lay people, it was a paper from experts for experts. So obviously, even when experts are communicating with each other, they are communicating in analogies. So why is this so? This can be explained by findings from cognitive linguistics in the end, from cognitive linguistics, from neuropsychology too. They have found that our understanding is embodied. Our understanding is embodied means that everything we understand we relate to some bodily experience. And of course there are concepts, there are ideas we can understand directly. So we know what an elephant is because we can see an elephant. We know what a chair is because we can sit on a chair. We call these embodied concepts. An embodied concept is a concept that arises from a direct bodily or social experience. On the other hand, we have concepts from science fields that cannot be experienced directly. You cannot experience thermodynamics directly. You cannot experience climate change directly. You cannot experience chemical equilibrium directly. So whenever it comes to these abstract fields, we need some direct bodily experience and transfer it and map it to the science field. And this is done via imagination. And this imagination, the tool we are using there is a metaphor, is an analogy. So for example, the idea that immune reaction is war does not do anything else than just map the experience of fighting to the abstract scientific idea of immune biology. So where does our experience start and where does our experience end? This is a very important thing to understand. Where are we using analogies and where are we using them not? Our experience is limited to a very small range in the end. It starts at a second and ends somewhere in decades. If we have a look at time, this is a range we can overview. Or if it comes to range, we can perceive things that have a tenth of a millimeter, a hair for example, and it ends somewhere in about 20 kilometers, so a horizon for example, we can see the horizon. Or when it comes to temperature, we can experience something between 0, the freezing point, and the boiling of water, so 100 degrees Celsius. Whenever we want to extend our experience, whenever we want to extend our perception, we have to use some special techniques. We have to use microscopes, for example, to dive into the microcosm, or we have to use satellites and remote sensoring to dive into the macrocosm. So we have to use technical tools, and this is something your students do not have, but you have. So whenever you want your students to understand something, and whenever you want your students really to develop an embodied understanding, you have two things you can do. You can either afford an experience, you can show a picture to them so that they can do the mapping on their own, or you can present an analogy, you can present a metaphor that helps your students to bridge the gap between a personal experience and the abstract science topic to be taught. Some of you might think that analogies are something you can use, but you don't have to use it. So these are some kind of educational tools that we have in our toolbox, and but we don't have to use them. And when we think about communicating really tough science content, we better do this without analogies. But in the end, not only communicating science is often done with analogies, and as I've shown you before, we have to do this. We cannot do something else than using these analogies. But often even the scientific endeavor proceeds with analogies too. For example, think of Kekulé, who was developing the idea of the benzene ring. He developed this idea by thinking of a snake biting into its own tail. Or if you think about Huygens, when he developed the idea of waves, light as wave-like, he was thinking about the behavior of waves in the water. Or if you think of Robert Boyle, who was doing research about elastic gas particles, he was thinking about coiled springs. So often, even when it comes to developing new ideas in science, they are using, and we are using, analogies, because in the end analogies are doing nothing else than models are doing. A model is doing nothing else than an analogy. We use some objects from everyday life and map them to the scientific content. So the question is not if to use analogies, but how to use analogies. And this we will show you in the next lesson.